All right, so the balancing act. Let's fill in the blanks first. So atoms are not blank or blank during a chemical reaction.
Created or destroyed.
They're not created or destroyed. All right, scientists know that there must be the blank number of atoms on each blank of the blank. What do y'all think? After looking at conservation of mass, what do y'all think?
Same.
There must be the same number of atoms on each side of the arrow. There's a few words we can put in here. Each side of the arrow. On each side of the arrow, or the, I'm going to say reaction. You can say chemical equation. To balance the equation, you must add blank in front of the chemical formulas in the equation. Coefficients. You must add coefficients. You cannot blank or blank subscripts. What do y'all think? You cannot add, I'm going to put add or change. You cannot add or change subscripts. So when we're doing this, we cannot mess with the subscripts. The only thing we can change is coefficients. All right, so let's do this example. It's got magnesium plus O2 is going to give us magnesium oxide. Notice that it already has done some things for us. It has boxes here to train us that we can only change the coefficients. And I will suggest you need to do this with a pencil because you might have to erase coefficients. Because a lot of this is back and forth when you get to some of the bigger equations. All right, so the first thing you want to do is you want to list your elements, which they've done for us on the front of this sheet. You want to make sure that they are in the same order. Okay, those elements need to be in the same order. And they are. So you've got magnesium and oxygen on the left, magnesium and oxygen on the right. And you need to divide this in your head. And if it helps you draw a line, but your arrow is your dividing point. Okay, that is your dividing point between the left side of the reaction and the right side. What are these on the left side of the reaction?
Reactants.
These are reactants and these are products. All right, so how many magnesium do I have right now in the reactants? 1. And how many oxygen do I have?
1, 2.
I have 2. Now how many magnesium on the right?
1.
1. And how many oxygen on the right? 1. In order to say that my reaction is balanced, the magnesiums have to all be the same and the oxygens have to be the same. Now, magnesium and oxygen doesn't have to be the same as each other, but the magnesium on the left has to be the same as the magnesium on the right. Oxygen on the left has to be the same as oxygen on the right. Okay? Y'all with me? Okay, so if I were to ask you, am I balanced, what would you say?
No.
No. What element is causing me not to be balanced?
Oxygen.
Oxygen. What coefficient could I put here? Because I can't change this one because I can't change the subscript. So what coefficient can I put here to give me 2 oxygen?
2.
If I put a 2 here, that changes my oxygen to 2, but what else does it change?
It changes your magnesium.
It changes magnesium. So now I've gotten my oxygen balanced, but in the process, I've thrown my magnesium out of balance. How do I fix magnesium here? What can I put in front of this to give me 2 magnesium?
2.
I put a 2. And that changes my magnesium count to 2. So down here, you're just tallying up how many of each element you have. Am I balanced?
Yes.
Yes, because my magnesiums are equal and my oxygens are equal. Well, I still have an empty box. What goes in that box? I can put a 1, and if it makes you feel better to put a 1, you go right ahead. But I don't have to put anything, because you don't have to write the coefficient 1. Okay? All right, let's go to the next one. All right, let's try calcium. All right, how many calciums on, I'm going to divide it. Now, you'll get to the point where you don't have to divide it. But if that helps you and helps you separate, then by all means, draw you a line there to divide it. How many calciums on the left? 1. Oxygens.
2.
How many calciums on the right?
1.
And oxygens?
1.
1. So am I balanced?
No.
No. My oxygen is out of balance again. I've got 2 on the left, so I need 2 on the right. What coefficient can I put here to give me 2 oxygens?
2.
2.
I can put a 2, and yes, that gives me 2 oxygen, but what else does that change?
2
Two
calcium.
It changes it to 2 calciums. Okay? Now be careful when you are changing these. Do not change these numbers until you put a coefficient here. Because the mistake a lot of people make is they'll change these numbers and then they'll forget to go back and put their coefficient. Then they've messed their whole problem up. Okay? So make sure that you put this first and then you change the counts here. So what's out of balance now?
Calcium.
Calcium. So I've got 2 here and 1 here. What number goes there?
2.
If I put a 2 here, that gives me 2 calcium. Am I balanced?
Yes.
Yes. And so you can either leave this blank or you can put a 1 there. Now these boxes will not continue to be on your problems. They're just here. This is a training exercise, so to speak. So they're just here to train you as to where to put them right now. All right, let's do our counts for nitrogen. How many nitrogen here?
2.
2. Hydrogen?
2.
All right, how many nitrogen on the right?
1.
1. And hydrogen?
3.
3. So, are we balanced?
No.
No, they're all out of balance. So, what looks like might be the easiest one to start with?
Probably nitrogen on the right.
Nitrogen is going to probably be the easiest one to start with. So, if I've got 2 on the left, how do I make 2 nitrogen on the right?
2. Add a coefficient.
I got to add a coefficient of 2. Does everybody see that? Now, if I put a 2 here, that's going to give me 2 nitrogen, and then 2 times 3 for hydrogen gives me 6 hydrogen. So am I balanced?
No.
No, I've got to get my hydrogen in check now. So here's hydrogen. What can I put here to give me 6 hydrogen?
3.
I put a 3, and then 3 times 2 is 6. Okay? And you can put a 1 here, or you can leave it blank, whatever you want to do. All right, let's try the next one. How many, notice, these are in the same order. Okay, even though it's not in the order of how it occurs in the reaction, they are in the same order listed. Why would you want them listed in the same order?
That way you don't get mixed up.
It's easier to compare. Okay, yes.
On the one that we're about to do, in that product, how come that O comes before the C? Because it comes before an interreactant.
You talking about here? Because we want to keep it listed in the same order. So they don't have to be in the order they are above them. They just have to be listed in the same order, because when you glance at it, you can say, oh, coppers, oxygens, carbons. It's easier to compare. All right, so how many coppers do we have on the left?
2.
2. Oxygens,
1.
1. Carbons, 1. How many copper on the right?
1.
Oxygen, 2. Carbon, 1. All right, so let's start with copper, because that would be really easy. Okay, there's 2 on the left. How do I make 2 on the right?
Add a coefficient.
I'm going to add a coefficient of 2, and that makes 2. All right, so carbons are in balance, so the next thing I need to go to is
Oxygen.
oxygen. I've got 2 on the right. How do I make 2 oxygen on the left?
You're gonna have to add a coefficient of 2 right there.
Add a 2.
Wait, what if you do that? Is that
Oh,
It affects the
copper
copper.
as well?
So that gives me 2 oxygen, but what does that do to my copper?
It multiplies it. It makes it 4.
I gotta do 2 times 2, and now I've got 4.
Now you gotta change code.
So now, this is why an eraser is so important. Now I've gotta go back. How do I make this 4 copper?
Add a coefficient of 4. Well, replace the 2.
Replace it. I've gotta get rid of this 2. Oh, my eraser is not. There we go. I've gotta get rid of that 2 and replace it with a 4. And so now I've got 4 copper. That's one reason I wanted to emphasize pencils are ideal for this, because you'll be doing a lot of, oh, I gotta change that, or I need to erase that. So now it's got 4. Is it balanced?
Yeah.
Yes, it's balanced. All right, so 1 and 1. All right, let's look at the bottom one. We have hydrogen and oxygen. So how many hydrogen on the left?
2.
2. Oxygen?
2.
2. On the right?
2 hydrogen. 3 oxygen.
2 hydrogen and 3 oxygen. So we got hydrogen's in balance, oxygen is out of balance.
Put a coefficient of 2 in front of the oxygen on the right.
Okay, so let me point out that this oxygen has a 2 subscript. It will never, you'll never get an odd number of oxygen on the left. Y'all see what I'm saying? Like, because anything I put here, you have to multiply by 2. So you will never get an odd number of oxygens. So we've got to make this number where it's an even number and we can equal it out. So the best way to do that is to put a 2 right here. Because if I put something right here, I still got to add 1 oxygen to it.
But that 2 will also mess with the hydrogen.
It also messes up the hydrogen. But what does it do to my oxygen? How many total oxygen do I have now?
6.
I have 2 times 1 is 2. Then I use the plus sign, plus 2. So 2 plus 2 gives me 4 oxygen. How many hydrogen do I have on this side now? 2 times 2 is 4, because remember, when I put that coefficient, it's going to change everything behind it. Okay? But the plus sign separates. So we've got 2 separate substances here, because that plus sign is a separator. So this 2 only affects the H2O behind it. All right, so how can I get 4 hydrogen on this side?
Put a 2.
I'm going to add a 2. So 2 times 2 is 4. And that also changes my oxygen. 2 times 2 is 4. And am I balanced?
Yeah.
Yes, I'm balanced. So there's a lot of back and forth, and you're going to have to be patient, because there's a lot of back and forth. Okay? Any questions? No? Good? All right.
You got it.